Hey guys, it's Greg. Welcome back. Today we're going to look at how to use Scikit-Learn's simple imputer to impute missing values into a data frame. So if we were to do this normal pandas read CSV into a data frame, pd.readCSV, I have data.csv here. What we get outputted is this data frame object here. And we can see these weird things, NaN for not a number. If we were to actually look at data.csv, which is what we're reading in here, it has these blank spots. It's just this missing information. Why does that happen? Well, sometimes as humans, we don't know the answer. We just don't actually remember to put something in there. It happens all the time, and this is going to come up a lot. So there's really three options that we have to do about this. One is to ignore this idea and just pretend it doesn't exist. That one's going to come back to bite us because if you do ignore it, if you do any sort of computation with this stuff, it's just going to break because you're trying to do manipulation with things that don't exist. So that's not good. We're not going to do that. Option number two, which is something we sometimes do, is just very easily remove all of the rows that have any instance of a not a number. So we'd remove this row and we'd remove that row and we'd be left with just this row, and this row, and all of it is numerical information. We're not going to run into any computation problems there at all. So that's fine, but the downside of that is we could lose a lot of information. So if we are actually losing a ton of the rows in our data frame, that could be a pretty big problem if we're going to run any sort of machine learning problem or analytics. And so we generally don't want to do that if we don't have to. Sometimes we do, but we don't want to. The third option, which is what we're going to do today, is Scikit-Learn's simple imputer, which is putting values into these not a numbers. And so basically we'd have to come up with a meaningful guess for this information. And so if we see here, this is 1, and this is 2, this is 4, and this is 4. Well, you know what's not a terrible guess for this value? It's probably wrong, but it's probably relatively close and reliable, is about 3, or 2.75. Specifically, we could take the average, or our mean value. So this is 1 plus 2 is 3, plus 4 is 7, plus 4 is 11, divided by 4, 1, 2, 3, 4. That is the average of all the actual values in that column. So the average is 11 divided by 4, which returns 2.75. So if we were to put 2.75 in here, it's not a bad guess, actually. It's pretty good. And same thing with here. If we took the average of this column for the actual numerical values we have, 5 plus 4 is 9, plus 7 is 16, plus 5 is 21, divided by 4 again. It's actually just going to be changing that. 21 divided by 4 is 5.25. If we were to put that value in here, that's not too bad at all. And so it's very easy to automate this stuff with Scikit-Learn simple imputer. We just go ahead, and if I delete these rows down here, I already have this here. So from sklearn.impute import simple imputer, that's the object. We get a variable, we'll call it impute mean, because we're going to do the mean or average like we just said. So we call simple imputer and set the strategy. So that's what the logic is for actually getting this, this value here to put in. The strategy is going to be mean. That's one of the options that it has. And that says, okay, get the average. We do impute mean dot fit the transform on that data frame object that we stored. And that is going to output this data frame right here, where it's actually not a data frame, sorry. This is going to output a NumPy array. If we wanted to get it back in a data frame, we could just kind of set the columns equal to the first column and the second column, but not going to do that. This returns a NumPy array of the information, and it inputted 2.75 into that spot there, and 5.25 into that spot there. So it did the average. Something else we might want to do is the median, because the problem with the mean sometimes is it's very prone to outliers. So if this value is actually like 1,000,000, which is just wrong, like it's not supposed to be like that, or it's really, really unlikely, then the value here, it would be way closer towards like 1,000,000 than it was to the actual close proper values, or more likely values anyway. And so we could use the median, and we do that exact same thing. We see here it inputted it with 3 instead, and that is because the two middle values are 2 and 4, and so we take the average of those as 3. For here, the two middle values are 5, and so it just returned 5 there. Okay, so that's the simple way to do the simple imputer, and that's what you'll do probably most of the time if you don't just get rid of the rows itself. If you were to get rid of the rows, it's actually very easy as well. If we did have df, you could also just do df.drop na, and that does exactly gets rid of those as well if you wanted to do that strategy. So some other options you might want to do for the imputation, you could do a constant value. So if you wanted, we could do strategies equal to constant, and by default, that's going to import 0 values. We can actually specify the value that you might want to put in there, like fill value is equal to maybe 1. Okay, so fill all of those with 1s instead. There's the 1, there's the 1. And something else you might want to do, because after we have this information, after we filled all of this in, we actually don't know anymore where we actually imputed values. Okay, so here it turns out that the second row and the third row is where we imputed some values here. But we lost where we did that, and so to do this, we are just going to specify this indicator thing. And so that's add indicator, by default set to false. We could set that to true. And here it added one column per each of these columns in here. So these two columns are still exactly like they were before. If we were to get rid of this, we see that it's the exact same thing, but it added these indicators, which just says, hey, if there's a 1 in this row and in this column, that means we imputed a value over here. And if there's 1 here, that means we imputed a value over here. Okay, so that's the idea. And yeah, so basically there's only one other thing that you might want to do. There's other complicated imputation ideas, but just one other very more common one and less complicated, because this stuff gets complicated very quickly on how you can impute stuff. And another good way to do it is to copy basically the same thing, except sklearn.impute, import the knn imputer, which is a k-nearest neighbors approach. And I'm not really going to explain what that does, but it is really just, if we were to get rid of fill value, we'll get rid of adding indicator as well. And strategy, actually, I don't think we need that. We'll do n neighbors, which is going to be just set that to 1 for now. N neighbors is equal to 1, and we'll say knn imp and knn imp. If we fit that transform, then we got it. No, that's not what I said. And neighbors, I am Canadian, and so I spell neighbors with a U, and that hits me all the time. So what this does is actually it changes this went to a 5 because its nearest neighbor was a 5, and this one, its nearest neighbor was a 1. Okay, so it's really just a kind of a more complicated, rigorous way to get more accurate imputation if you want to do that. But I find that the mean and the median are really good choices, so I wouldn't worry too much about that. Okay, so if this helped you out, drop a like and subscribe if you're not, and I'll see you next time, guys. Thanks.